So we have this summary. For a series circuit, the EMF or the potential difference across the cell is the sum of the different potential difference for the components. Then the current, because there's only one path where the current can travel, so current is always the same. Then the effective resistance is just add up the two resistors or three resistors, depending on how many resistors you have in the circuit. Then for the parallel circuit, you see that the potential difference is the same across all resistors. Then the total current is the sum of the current in each individual branch. Then the effective resistance is like this. Then one of the things is you shouldn't miss out this one because it will give you a totally different answer. So now the questions from here, right, onwards, right, are all a mix of parallel and series together. Okay, so you can use whatever knowledge that you have and attempt all these questions. First do 1 over Q plus 1 over R. Calculate the effective resistance of Q and R. 1 over 6 plus 1 over 6, 1 over 3. Okay, this is part B. So over here is 3 ohms. So R effective is okay. So this is 3 ohms. Here is 7 ohms. So then they say determine the potential difference for PQ and R. This one is which one? So why divide by 2? Okay, so this will become, so when you have your total resistance, effective resistance is like this. So then the current going through this is 0.2. Then you want the PD here. So it's PD will be D equals to I times R. R is 4 ohms. Current going through the 4 ohms is 0.2. So this is not like that. So for the potential across P is this. Then you can't do 1.4 split into 2 because this resistance and this resistance here is not equal. You get what I mean? Yeah. You can only 1.4 divided by 2 if you see that on the left side and the right side, right, the total resistance is equal. Let's say 4 on the left and 4 on the right. Then you can divide by 2. If not, you will have to use V equals to IR. Okay, that's the P. Let's go to the other two. So 0.2 comes into this branch and splits into 2.
That means the PD is just 1.4 minus 0.
Yes. So VQ equals to VR because it's parallel there equals to 1.4 minus 0.8. Okay.
Yeah.
So we had here is 0.8. So 1.6 divided by minus 0.8. This is 0.6 here. Then down here, then this is 0.2 amps. Determine the current flow in Q and R. That means here, current Q, current R. I equals to V over R. So you 0.6 divided by 6. Yes. There's another way to do it. You notice over here, I drew 0.2 down there.
0.
Yeah.
Divided by 2.
Yes. Why divide by 2?
Because it's parallel and there's 2 pathways for the current to go.
Not true. That you are missing some very important piece of information. It is divided by 2, but why? You look at the resistance.
The resistance blocks some of the current from going.
No, it's like this because the resistance here is 6 ohms, the resistance here is also 6 ohms. So because the two resistance are the same, so the current will split equally. Then it becomes 0.1. When the resistance is the same, the current split equally. Okay, but if you have say 0.3 amps and then split into 2 branches again, one side is say 2 ohms, then the other side is 1 ohm.
Then must use V equals to IR.
But you don't have V down here, so how?
That must find the voltage for both.
You can just use the proportion. So you know 0.3 amps, right, will split into 2 parts. One for the 2 ohms, one for 1 ohm. So because there are 3 ohms, you can split this into 3 parts. So you take this divide by 3. So 0.1. Then the one, right, that has the higher
will have the lower
0.1. We have the 0.1. Then the other one will have the 0.2. So you split the current into 3 parts. Then the one with the higher resistance will have the lower one?
Means the one with higher resistance have less current go through.
Yes, because you say already, the resistance will block the current, right?
Yeah.
Because of the resistance, current find it difficult to pass through. So then the current block, so current gets blocked. So the path with higher resistance have lower current. Okay?
Yeah.
This drawing looks a bit different. You may need to redraw the diagram. So down here, this section is all about circuit diagram redrawing and then using formula. More complicated than the earlier questions. And these are the questions that you see in your test. R effective of the parallel is 8 minus 6. Where did that come from?
Because the X is 6 ohms.
Mm.
The effective resistance of the whole circuit is 8.
Yes. Mm-hmm. Okay, then what's Y? What's the resistance of Y? So this can be redrawn into X. 3 ohms. So you are doing 1 over 2 is equals to 1 over Ry plus 1 over 6, right?
Yeah.
What is the current at P? If you redraw this, it actually gives you current at P is 12 volts, and the whole circuit, the effective resistance is 8 ohms. Then this current at P will flow through here and then split into two, which is I, Y, and I, Z. So this IP is actually the total current.
1.5 divided by 8.
So you draw out and see where the current is at. Then you decide on what to use to divide.
X having its own resistance is a trick.
Yes, that's why I say you might need to redraw the thing.
Means this is one of the trick questions.
One of the questions that you need to know that the current that's going into X is actually the mean current, which is the IP. So then if they ask for IY and IZ, then you can know that it has to split and then that number becomes different. Actually, if they ask for IY and IZ, is even more difficult, right?
Yeah.
Indicate the direction of the current flow. I sort of gave you the answer just now. Current flows from positive to negative. So it's like this. It's this way. Then, okay, the irritating one is here. What was Y again? Y is 3 ohms. Then the current was 1.5. Why 6 divided by 6?
Because the voltage splits equally.
You sure it splits equally? Let's redraw. Let's draw that drawing again. So this is 6 ohms, which is the X.
The voltage is the same.
Down here, this is the Y, and then Z is 6 ohms. So then over here is 1.5 amps. That means 1.5 amps here, right? So 1.5 amps splits into, this side is 3 ohms, this side is 6 ohms. And you know this is 12 volts. So first way to do it is use this method where you study how the current splits using the ratio, which will be, that means this is the ratio of 1:2. So then that means on the Y side, what you do is you take 1.5 divide by 3, you get 0.5 amps. Then that means the current will split into two, 1:2. So one is 0.5, the other one is 1 ampere. So then I can go to here, right? The one with the higher resistance will have lower current. So it's 0.5 and 1 ampere. This is method 1. Okay, method 2 is like this. Let me change my pen color. Okay, so using this drawing again, okay, I circle out the drawing here. We use this. Then I can find the potential across X, which in turn give me the potential across Y, across the V, Y and Z. So Vx is IR, so it's 1.5 because 1.5 ampere flows through X times this. Gives me 9 volts. That means the potential across Y is equals to potential across Z, because they are in parallel, is 12 minus 9 equals to 3 volts. So here is 3 volts.
3 divided by 6.
Then current equals to V over R. Then 3 divided by 6, then you get 0.5. by. That's for Z. This one is method 2. If the ratio one is difficult, then you will just use method 2. But method 2 is a little longer. This drawing looks not nice, right?
Yeah.
It looks terrible. So one thing you can do is you redraw. So if you kind of redraw, it actually becomes this one is this one. Okay. Then because of these two drawings here, you split up into like that. So this two is this two. Then below there's another two. So same thing. So this is okay. I just use different symbol so you know which one is which one. Then this one is this one, 24 volts. So because this is 8 volts here, you can find the potential over there. Then they say the resistor is 2 ohms each. Then this is 2 ohms here. You don't need much. You don't need much to find part A because you're given the potential across that resistor and you're given the resistance of the resistor. Why 24 divided by 2 again? V over R. Then your R is only 2 meh? If you want current of I1, then you should be finding V divided by total resistance. If you're looking for I1 here, I assume it's this.
Yeah.
Yeah. Then this is the main current going through here, going to this one and this massive network. So if you want to find I1, then it's actually the total D, right, which is 24 divided by the R effective of the whole circuit. So it is not 2, unless you tell me that when you calculated and the R effective is 2, just not likely. So let's look at just part A.
3.6, the R effective.
3.6. So it's 1 over R effective equals to, okay, not R effective, I call it R parallel because this one is the parallel branch one. It's 1 over 4 plus 1 over 4 plus 1 over 2.
1 over 8. The top and bottom one is 4. The middle one is 8.
Middle one where got 8?
Middle one is
2.
8 volts.
But your formula is using resistance.
Yeah.
So every resistor is 2 ohms. So it's 1 over 4 for the top branch, 1 over 4 for the bottom branch, and the middle branch is 1 over 2. So R parallel is 1. So then the R effective is this is 2. So it's 2 plus 1 is 3 ohms. But to find the current flowing through the resistor with 8 volts, right? You don't have to go through so much trouble. Let me single out that one for you. You see it's 8 volts and they tell you the resistance is 2 ohms. Then current is how much?
8.
Current is how much? 8. Why 8?
The total current.
Oh, you're saying the total current. Yeah, total current is 8. I1 is 8. Okay, so then back to here, I'm talking about part A here. To find the current within the resistors with 8 volts, right? I single out, I draw like that. So it's a 2 ohms with 8 volts and a unknown current flowing through it. So here, right, that means current equals to V over R. So it is 8 divided by 2. So it's 4 ampere. You see?
Yeah.
So, but we found the R effective is 3 ohms. See, the second part, they say calculate the R effective resistance of the circuit. We found it is 3 ohms, right?
Yeah.
Then they say current flowing in the main circuit, it was 24 divided by 3. So it's what, 8 amperes, all from part 1. So we found that too. Another scary looking one. This one tests your current splitting skills again. Okay, so you have 6 volts. So I equals to V over R. So it's 6 divided by 12. Yep. So here is 0.5 amps. And down here is 6 volts.
They already gave the PD. Why they ask to calculate the PD?
Because this is a fake PD, fake parallel down here. You have to redraw. Once you redraw, you will recognize it's a fake. So what happened is, if you redraw it, you will see that QR 3 ohms, 9 ohms. Then it will become your P down here, which is 6 ohms. Then you'll get your S and T down here, which is 4 ohms and 12 ohms. You see? Then your S PD is 6 volts, so 6 volts is here. Then you found that this is 0.5 ampere, right?
Yeah.
Yeah, then this EMF is unknown. That's why they say calculate the PD in R, because the PD across R wasn't given at all. It's just the way they draw it and make it look like it's given. And QR is parallel to each other, S and T is parallel to each other. But QR and S and T, they are not parallel to each other. That's the tricky thing. Current in S is V over R. 6 over R. You get 1.5. Then, so the current total is how much? So it's 2 amps here. So 2 amps flow from here and will flow to this side. So I total is also here at 2 amps. So then you notice this happens a lot. 2 ampere splits into IQ and IR. This side has 9 ohms. This side has 3 ohms. Familiar? So IQ, RQ is to RR is 3 is to 9, 1 is to 3. So your current 2 ohms, 2 ampere will split into 2 parts. So 2 amps will be split into 0.5 amps and 1.5 amps, right?
Yeah.
Then, so now which resistor takes 0.5 and which resistor take 1.5?
Q takes 1.5, R takes 0.5.
See? So you got your answer. Current is 0.5. Then PD in R is I times R. Get that? Yeah. So then the EMF of the source. So let's go back to this. Okay. Our information is this is 6 volts, then 4.5 is here, 4.5 is here. Then the current flowing through I total is 2 amps. Right? So what is the EMF of the source? So back to that drawing that we have just now, you have this one, which is 4.5 volts. Then this one is the P with 6 ohms. Then this one is the one where S has a PD of 6 volts. Then current 2 ampere.
1 over 3 plus 1 over 9 plus 1 over 4 plus 1 over 12.
I told you these 4 are not in parallel already. So you don't have to use that. And I gave you this drawing, you see. So the EMF here, you see the EMF? Yeah. And then the EMF is, that EMF, if you look at this diagram, means it's 4.5 volts plus the VP plus the 6 volts, because the EMF is parallel to these 3 resistors. And this one is this one, and this one is this one. Because we already find the potential difference, and the top one, the Q is parallel to R, so I can use the potential like that. Then the S and T, they are parallel to each other, so I can use the potential over here at 6 volts. So then we're left with VP down here, we do not know the potential. Then the EMF is the sum of all these 3 together. So your job is to just find VP is how much?
2 times 6, 12.
So then you'll be 4.5 plus 12 plus 6.
22.5.
Yeah, like that. Determine the overall resistance. So then this one, the drawing is like this. Okay, the first one is this. Then this is 6 ohms. Then this is 4. It's like this. You have total current is 2 amps. You have the total, then you have the total potential is 22.5. Then can find the total resistance or not. With the info given to you, can you find it? Yeah, you can find it like that because you have the total current and you have the total potential. If you want to use the R effective method, then you have to find the R effective of this. Then you have to find the R effective here, then series with this one, which has a longer working. You can do that, but the working damn long. What is the PD between A and B? So just now you found that the PD here is 12 volts. Then B is here, which is 6 volts. So the PD between A and B is here to here. Yeah.